One.
Okay, so for today, we're going to be talking about Euler's method, which is kind of similar to what we did last class, but instead of it being more of like a general sketch when you're like connecting all the slopes of a slope field together, it's more like a specific like connecting the slope fields, if that makes any sense. So instead of just like drawing like an arbitrary curve, it's more, I guess, more mathematic in that you're connecting one slope field to another until you have the curve. So basically, you can have like a step size, which, if you think about it, the larger the step size, the less accurate your curve is going to be to the actual like function that you're trying to represent. Whereas, smaller step sizes means you're connecting closer and closer slopes together, which means you'll obviously have a much smoother curve. I guess it's mostly it for Euler's method. It was pretty simple.
Yeah.
You want to keep going?
Yeah. So the second half of the lesson on 11.4, he talks about separation of variables. And essentially, what you're trying to find here is the differential equation to be able to find your slope field. And there's some cases where you have two functions multiplied by each other, and it's difficult to find a particular slope field with two variables. And so what you would do here is so because it's in terms of dy dx, you can manipulate this function in a way that you're not typically used to, or you're not typically allowed to. But in this case, it makes sense to do it because dy over dx just means a change in x, change in y and change of x. You're just accounting for that rather than using a random variable. And so if when you solve for each variable on different sides of the equation, so in terms of y and in terms of x, you're able to, and then once you do that, you're able to actually integrate it in terms of dy and dx separately. You're able to find your differential equation that you use to plot your slope field. What's particular about this is that it does not work for every scenario. So it works in terms of like you're multiplying two functions, so like g of x and f of y. But in terms of like sine of x plus y, there's just no way to use this method. You can manipulate it in several ways, like say you take the inverse of the function, which would then equal the inverse of the dy over dx equals x plus y. So you have your x plus y outside of the isolated, but you still have the dy over dx inside of the sine function that you cannot separate from that. And so why this is important to use separation of variables is because this method will be used in a lot of the more real life examples that were given in terms of like finding pressure and temperature. And so from the notes, we're supposed to go over a problem that we can all do together. Yeah, so the function, I can write it. Share my
Yeah, I can screen share or pull up a whiteboard.
Sure. Okay, so the function is dA over dB.
Wait, hold on.
Minus 3b squared over sine of A equals 0. So we're supposed to find a solution of this, and then after we find the solution, we plug in variables. Yeah, so I guess we would just and then multiply sine over and dv over.
Mm-hmm.
Yeah, this makes
Yeah.
sense. And then you can just differentiate. You put sine of d.
Whoops.
Also, it'll be easier if you write the change in the function after the.
So what do you mean?
So like sine of a of d times dA. So it's easier to see that we can take the.
Oh, okay.
Wouldn't it be dA over sine of a? Wait a minute. If you
No, it's gonna be sine of ADA.
okay.
Because you cross multiply.
Oh,
Yeah.
never mind. Yeah.
Right. Okay. So now you can integrate both sides. In which sine, cosine,
Negative
left side.
cosine.
yes.
Okay.
The left will be negative cosine. Plus c. Or no, there's no db left.
Yeah.
Oh,
So
whoops.
that's b cubed plus c.
My bad.
You're all good.
No
You're all
worries.
good.
C.
And then so you can cancel one of the c's. And then you can isolate it in that,
Mhm.
yeah, or it's negative b cubed.
Yeah, you're right.
Well, you can also just write b cubed.
Yeah, and have it be plus cosine.
Negative
Yeah,
c.
but I think that makes it
Oh
harder.
no.
Yeah, b cubed plus cosine.
Well, this is
But
gonna
equals
be.
negative c, and you have to distribute it anyway. I mean, I guess it doesn't matter.
It wouldn't be negative c because you can just keep, because we can choose which c to
You're
keep.
right. You're right. You're right.
Oh yeah,
The c is itself, right? You're right.
that's interesting. So we can make this entire thing positive.
Yeah.
So if we have cosine a plus b cubed equals
Yeah.
c.
Yeah.
That's
And
so
what
weird.
William said is right, that c is just a constant and it's variable, and so it doesn't matter how you
I don't know
write.
why I wrote so crooked like that. My
No
bad.
worries.
You're all good.
Okay. So we have our differential equation now, and we're gonna find a solution when a equals b. Sorry, a equals 0 and b equals 0. In which, so I guess that means that separately, right? When a separately 0, b separately 0, not together, I think.
C cubed equals c. So when a equals 0 and then b equals 0.
Yeah. So when a is 0, cosine 0 is 1, right? Yeah.
1 plus 0. So that's gonna equal 1.
Yeah, c equals 1. And then for b, it would just
B.
cosine of a. But I'm wondering, what does this tell us?
C equals 1 because we're looking for the value of c.
It tells
right?
us. It tells us like
Yeah, c equals 1.
the radius, sort of, but this isn't a circle, so.
Oh, right, because this
No
is
way
the
to tell.
this is the function for a circle.
Well, it's not.
Right.
It's not a circle.
Well, the like a squared plus b means b cubed. It's not b squared, but a squared plus b squared equals c. No, equals r equals the circle. In which the slope field like just like makes a circle in each individual slopes. Okay, well, we can do it for b then. So, oh wait, we did do it for b. Oh, that's what you.
Yeah,
oh, never
because you
mind.
can't. Yeah, I think you have to do
Right,
it both
right.
at the same time.
Right. Okay, so 1, that's equals 1. So you guys said, so I do have a question. I'm a little confused on what that represents. So you said it represents the radius of
I don't know. That
It's
was
not a
just a guess,
circle.
but
It's not a circle.
So
Okay, so it represents each individual's slope, or if anybody has an idea, or Andy, if any you have a clue as well.
Well, not all of these are going to be that straightforward to visualize, right?
Right.
So like maybe at this point, I don't know if you guys aren't asked to go farther than just solving for this, right? I mean, you could plot it. You could, I guess, kind of try to break it apart and see if you understand it. But honestly, at the point that you guys are at now, I think it's totally fine.
Cool. Thank you.
okay.
Stop.
Oh wait, William, you're muted.
So this is it. We just need to find what C equals.
No, we did. C equals
We
1.
get
Yeah, we already did.
Yeah, I'm saying that's all we need to do.
Oh
Yeah, I
yeah,
guess so.
yeah. It's just solve in terms of A and B.
Is there anything else we need to do for today?
That's about it.
I
Yeah,
don't
that's
think
it.
so.
Okay. I'm gonna stop recording.